Hi, my name is Ji Young Yu. I am a PhD candidate in Harbin Institute of Technology, in China, and will now present our paper Deep Bayesian Video Frame Interpolation. This work is done during my internship at SenseTime with multiple collaborators coming from SenseTime, Tetras, Beihang University and Shanghai Jiao Tong University. If viewed from optimization perspective, continuous time VFI methods predict the parameters, for example, flows and occlusion, for a renderer to best explain the measurements. Since there are far more predictive parameters than measurements, effective priors are required. In most contemporary works, parameters are predicted from sparse measurements in one pass, having few chance to feedback and improve rendering errors. Consequently, burden is left to the network to encode strong priors into the parameters, which is prohibitively difficult even for large architecture. In this work, we start from a different perspective, treating directly the inverse problem nature of VFI and solving it with gradient-based Bayesian optimization. Our approach learns posterior distributions of optical flows and frames to be interpolated, which is optimized via learned gradient descent for fast convergence. Each learned step is a lightweight network manipulating gradients of the log likelihood of estimated frames and flows. Such gradients, parameterized either explicitly or implicitly, model the fidelity of current estimations when matching real image and flow distributions to explain the input observations. Each iteration requires evaluating specific log likelihood gradients. We show that gradients corresponding to the incremental image has explicit and interpretable representations under simple distributions, resembling warped reconstruction errors with current flow estimations. For the flow log likelihood gradients, we propose an implicit representation via deep parameterization to make them tractable and computationally efficient. After calculated, image and flow gradients are concatenated with other conditional inputs and fed into the shared CNN, where two residual and residual U-net blocks, RRUB, are adopted. Now comes to the experiments. We evaluate extensively on 10 benchmarks: GoPro, Adobe 240, X4K 1000 fps, Vimeo -90 kelvins, UCF 101, Davis and the easy, medium, hard and extreme subsets from SNU film. Among them, GoPro, X4K 1000 fps and Adobe 240 are used to evaluate 8 times interpolation, while others are 2 times. Evaluated with extensive experiments, this method sets new records on 8 of 10 public benchmarks, outperforms state-of-the-art methods. Here are some visual results. That's all, thanks.